A couple decides to save money for their child's first year college tuition. Parents will deposit 1,700 n months from now and another 3,400 2n months from now. All deposits earn interest at a nominal annual rate of 7.2% compounded monthly. Calculate the maximum integral value of n such that the parents will have accumulated at least 6,500 5 years from today. So there are two deposits, 1,700 happening n months from today and 3,400 happening 2n months from today. And we are looking at accumulating at least 6,500 5 years from today. So first we calculate the effective monthly rate because we are given the nominal rate compounded monthly, and the effective monthly rate comes out to be I12 by 12. Let's call it J. And the nominal rate was 7.2%. So J will be 0.072 by 12, which is 0.006. So since we're talking about accumulating something 5 years from today, so we convert the 5 years into months, and that would be 60 months. And so the time diagram is as here. So 1,700 deposit was made n years from today. 3,400 was made 2n years from today. And okay, it was made n months from today. And let's go back and look at it. Okay, so this was n months from today and 2n months from today. Okay, and the last, as we said, the last time of interest is the 5 years from today, which is 60 months. So we see from this time diagram that the first deposit, which was done at time n, so now we're just talking months, it sits for 60 minus n months in order to accumulate, while the second deposit, which is happening at 2n, sits for 60 minus 2n to accumulate. So the sum of these two accumulated amounts, this n and this 2n, we want that to be at least 6,500. So first we set it equal to 6,500, and the accumulated value is found for each deposit separately according to the basic compound interest formula. So for the 1,700, it would be 1,700 times 1 plus I, so 1.006. We're talking monthly rate because everything is in months. And the 60 minus n is the number of months that it sits in the account. Similarly, the second deposit was 3,400, and that times 1.006 power 60 minus 2n gives us the accumulated value of the second deposit at time 60. And we're setting the 2 equal to 6,500. And in the next step, we break up this 60 minus n power. So we break this up into 1.006 power 60 and 1.006 power negative n. And similarly, the 31, the other term is 1.006 power 60 and 1.006 power negative 2n. And now, if we simplify all this expression, just leaving the 1.006 power negative n, so the other term becomes 24.34, and here the other term becomes 48.68. And now we can let the 1.006 power n equals to x so that it looks like a quadratic equation, the kind of form that we are familiar with. So we rearrange the terms. We write this one first because if the power negative n was x, then the power negative 2n would be x squared. So you get 48.68 x squared plus 24.34x, and we bring the 65 on the left, so it becomes negative 65 equal to 0. And then we apply the quadratic formula. Only the positive value is of interest because x is this exponential, which can never be negative. and x comes out to be 0.9323, and then we replace x with what it was, 1.006 power negative n, take natural log of both sides, and we finally get n equals 11.7 when we divide both sides by negative ln 1.006. Now, from the time diagram, we see that accumulation will be lower for higher n. So what our calculations are revealing right now is that when n is 11.7, the accumulation will be 6,500. So when n is 11.7, accumulation will be 6,500. So now, if we reduce the n, so it means if we go on this side, so that means this one will also move on the left side, and reducing the n, so right now n is 11.7, so imagine this to be 11.7. So if you reduce it, then this 1700 actually sits for a longer time, because the 1700 is sitting for 60 minus n. So right now, think of 60 minus 11.7, which is 48.3. But let's say we move it further on the left, and instead of 11.7, we go to 11. So then it would be 60 minus 11. So that'd be 49. And that's more than the 48.3. So sitting for 49 months, it will accumulate to a higher value as opposed to sitting for 48.3 months. So same for this one, because as n moves to the left, the 2n will move to the left, and 3400 will have more time to sit until time 60. So what that means is that if we reduce n, the accumulation becomes larger. Remember, we wanted the accumulation to be at least 6,500. So the accumulated value will be at least 6,500. So if you move lower than the 11.7 you got, 11.7 would result in exactly 6,500. If you move lower than 11.7, you will do more than 6,500. So you're satisfying the condition of being at least 6,500 if you choose n to be 11. On the other hand, if you choose n to be 12, now you're moving on this side, on the right side, which means the accumulated value will be less, because now this one will have less time to sit. Similarly, this one will also move to the right, which means it will have less time until time 60. And that will result in lesser accumulated amount. So it means we can't have n equals 12, because that will give us less than 6,500. Whereas n is equal to 11 will give us more than 6,500. And the condition was that you want at least 6,500. And we are finding that n has to be 11. The maximum integral value of n that will accumulate at least 6,500 is 11. So now note that if n is reduced even further, so right now this n at 11.7 gives exactly 6,500. Now, if you reduce it very much lower than 11, let's say 10 or 9 or 8, then you would accumulate it even more, and you're still satisfying the condition that you're accumulating at least 6,500. But we want the largest possible n. So the largest possible n that does this job is 11, because once you go to 12, you get less than 6,500. So the correct answer is A.